So I'm Tom Johnson. I'm an instructor for the VACT 2297 thin film deposition course. So what's the motivation for this course in the series? Well, we think that since technicians are tasked with more than just making the vacuum system work, they need a more holistic troubleshooting tool belt. They need to understand kind of the core technology that goes along with vacuum systems, specifically deposition, which is very popular use of the technology. And we just think that technicians are more valuable if they understand what's happening inside the chamber. So I know that's kind of been the realm of the process engineer, but the process engineer is probably trying to communicate to the vacuum technician, well, I need it to do this. You know, what can we do to make it do this? So to the extent that the technician has that knowledge, it'll help them communicate and help them troubleshoot and be more effective. So this is kind of a typical course outline that of the topics that we cover in VACT 2297. We start out with a foundation in material science, the structure of solid materials and their properties. And then we look at thin films and how they're deposited with the two PVD core technologies that we have at our disposal, which is sputtering and evaporation. And then we also have to characterize them to make some sense out of what we just did. So we have a couple tools, a profilometer, 4-point probe, and a spectrometer that we utilize to help us understand those thin films.
Frank, thank you for
our flagship sputtering system now that we just got online this year is the Kurt Lesker Nano 36 system. It's an RF and DC magnetron sputtering system. It's got substrate heating and rotation, film thickness monitor, which is great, and dual mass flow controllers, which also extends the capability to reactive type depositions. So not only can we do just metals, we can do metals and oxides, metals and nitrides, which gives us so many more possibilities. And the best part about this system, as Bob had explained earlier, that this is has remote operational capability. You can see there's a laptop set up right in front of it. It has a HMI, a human machine interface, that resides on there that lets you control the deposition system completely through the PC. And then with a Zoom session like this, we can extend that capability remotely to our students. So I'm going to show you a demonstration in a little bit about that shows students operating the system. Just a couple notes on some other things. So I'll show a little video. It's going to show a typical lab that we do with our students, depositing various thicknesses of thin films, in this case aluminum on glass. Characterization equipment. It's also important for the students to have remote operational capability on the characterization equipment, and we just got that capability this year as well. So students can use this profilometer made by KLA 10 Core to measure the film thicknesses, and you'll see that in the video as well. So you'll see a student operating the equipment with guidance from myself, and and it really aids in the understanding of what's going on. And then finally, we're going to be looking at, in our video, characterization of optical properties using a spectrometer. We have a very simple setup, but it's highly effective for what we're using it for. It's a light source fiber optically coupled to a stage, which shines that light through our specimen, and then that light that makes it through our specimen wraps around and goes into the spectrometer, which is coupled to our PC, and you'll see the output of that spectrometer on the PC in that video as well. So that's been a great addition to our characterization capabilities as well. So I'm going to start the video. And you'll see the students operate the equipment. Light can interact with a solid material in 3 different ways. Light can pass through some solid materials in the form of light transmission. It also can be reflected off the surface. And finally, it can also be absorbed into the material, typically as thermal energy. Some materials have a percentage of all 3 components. The sum of each contribution must add up to 100%. We're going to take a look at a practical application of optical properties today. Thin films are used to alter the optical properties of glass. Today we will deposit a series of aluminum thin films of 60, 80, 100, and 120 nanometers. And after deposition, we'll verify the film thickness on a profilometer and then measure the transmission and reflection of light on these samples with a spectrometer. We'll wait for the system to get down to base pressure. Okay, boss, we are down to base pressure. It's showtime. We can start our preparation for deposition. Let's go to the recipe editor and pick DC magnetron deposition with film thickness monitor. Change a couple parameters. Let's slow the substrate rotation down to 5. Our dwell time at 60, and our thickness will be 0.08. And as soon as you have that updated, hit continue load, and we'll add our argon gas and wait for the pressure to stabilize. And once we get our pressure and our power up, looks like we got 5 seconds. It's going to go fast, so keep an eye out for the shutter. There it goes. We are depositing material now. Let me adjust the camera a little bit. There we go. It doesn't take long with these very thin films. And that's it. Okay, go ahead and engage the stylus. Bring it down to the surface, and once it's down there, go ahead and start the scan. And we'll have to keep an eye on it because it's such a thin film, where it actually crosses the step. So right about there is where we want to look for our step. Okay, we'll see what kind of results we get. level our data here. Bring that cursor, the right cursor, up to the top of the step, just beyond that, that big peak. Bring it back a little bit. Perfect. What do we got there? About 92.9 angstroms. Nice. We're going to take a look at the light transmitted through the slide, both with and without a thin film. So we can see the difference between without a thin film and with a thin film. We'll just record that as a percentage. There we go. And that should do it. So that was in a very abbreviated day in the lab of thin film deposition class. Anybody that's operated that equipment knows there's a lot of wait time in between. So just kind of gives you an idea of what goes on in the class. Anybody have any questions about the thin film deposition course?
Yep. And Tom, it's probably worth noting, if it wasn't obvious, that that entire demonstration was done by a student remotely.
That is correct, yeah. So even though I was kind of talking over, students were actually doing the manipulation of the equipment remotely.
What you're saying, this is that students then, like all the way down in Texas, could they hook up then, are you saying, with a laptop computer and actually operate that piece of equipment then in your lab there in Minnesota?
That is correct, yep. So so we had our students in Texas and California all participate remotely by operating the equipment.
All right, very cool.